Welcome. On this video, we're going to discuss inverse functions. Here you see three graphs. Every graph that we have is called a relation. So these are three relations. We've talked about functions and the vertical line test previously. Notice that in this first relation that it's not a function, because a vertical line intersects it at more than one point. So the graph in figure A does not represent a function since the graph does not pass the vertical line test. A vertical line can intersect it at more than one point. If it does, it's not a function. However, look at figure B and C. Vertical lines will only intersect it one time, not twice. So the graphs in figure B and figure C do represent functions because they pass the vertical line test. So if a vertical line intersects a graph at more than one point, it's not a function. Now we're going to talk about a more specific type of function, and that's called a one-to-one function. We've talked about the vertical line test. Well, there's a similar test called the horizontal line test, only our line is horizontal. So if you could place a horizontal line anywhere on the graph, if the line intersects the graph in at most one point, then the graph passes the horizontal line test and therefore represents a one-to-one function. So a one-to-one function, first of all, must be a function. Therefore, it passes the vertical line test. Second, to be a one-to-one function, it must also pass the horizontal line test. So simply stated, a one-to-one function passes both the vertical line test and the horizontal line test. So for a function to be a one-to-one function, a vertical line can only intersect it once, and a horizontal line can only intersect it once. Let's consider these two functions. Both figure A and figure B do represent functions because a vertical line will only intersect each of them once. So we want to know, are they one-to-one functions? Well, let's look at the first one. If you draw a horizontal line anywhere on the graph, it will intersect at only one point. So this graph, figure A, is called a one-to-one function. Another way of saying that is that every value of f of x, so every y value, is associated with only one x value. So if I draw that horizontal line, it only crosses one time. Again, that last sentence is a little complicated. Every y value is associated with only one x value. Okay, let's look at the next one. It's a function because if you draw a vertical line, it intersects only one time. The question is it a one-to-one function? If you draw a horizontal line, how many times will it intersect? Well, if we draw a horizontal line, it will hit twice. So this graph, figure B, does not represent a one-to-one function because the horizontal line can be placed in such a way that it intersects the graph at more than one point, and therefore fails the horizontal line test. Going back to that last example, every value of f of x, every y value is associated with only one x value. So looking at the graph on figure B, look at the y value of 3. It has two different x values. When x is 1, y is 3. And probably when x is 3, also y is 3. Okay, so the same y value can have two different x values at multiple points, at an infinite number of points actually. I know it gets complicated, but for right now, just keep in mind a one-to-one function must pass the vertical line test and the horizontal line test. Okay, so let's look at this one. Is this a one-to-one function? So it does pass the vertical line test. Does it pass the horizontal line test? So it is possible to draw a horizontal line that intersects the graph at more than one point. For example, right there. This horizontal line that I just drew in red intersects it how many times? Right, 3 times. So this graph is not a one-to-one function because it fails the horizontal line test. How about this graph? It is a function because the vertical line intersects it only once, but a horizontal line, yeah, it'll intersect it only once. So this one does pass the horizontal line test. So this is a one-to-one function. All right, now we're going to have to graph our function and then determine if it's one-to-one. So we have to remember some of our rules about graphing. Here we have a square root function. What is the first thing we do when we're graphing a square root function? Right, we find the domain. So to find the domain, you set the radicand greater than or equal to 0. Well, that just gives us x is greater than or equal to 0, so our domain is from 0 to infinity. So let's pick some points. We could pick 0. If we pick 0, what do we get? 0, right. Square root of 0 is 0. 1 would be another good value to choose because the square root of 1 is 1. So we're picking numbers that are in the domain and working it out. 4 would be a good number to choose also, because what is the square root of 4? Right, 2. How about one more? Good, 9. Square root of 9 is 3. Plot your points. Okay, draw in your graph. So the next question is that a one-to-one function? If I draw a horizontal line, does it intersect at only one point? Yeah. It does, only one point, not 2 or 3. Anywhere you draw it, only one point. So this is a one-to-one function. Here's our next graph. X squared minus 3. This is a parabola. So we'll pick 0. And then we'll choose 2 numbers to the left and 2 numbers to the right. This one does not have parentheses, so that's why we're starting with 0. And then -1 and -2, and +1, +2. 2 to the left, 2 to the right. Plug those in by hand or use your calculator. When you choose 0, you should get -3. All right, so you have -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. Again, each of those, replace x with those numbers and work it out, and you should get those same numbers. Plot your points. You can already tell it's a U shape, a parabola. So now we perform the horizontal line test. A horizontal line can intersect this graph at more than one point. So this graph fails the horizontal line test. Therefore, it is not a one-to-one function. This is a little good review on graphing. So this is the title of the section, Inverse Functions. We had to talk about one-to-one functions so that we could get to what an inverse function is. If a function is a one-to-one function, then it has an inverse function. So that's the key. It has to be a one-to-one function for us to even discuss an inverse function. So there's some properties of functions that we have, and f and g are the functions, and if they're inverses of each other. So here's the first property, that the composition f of g and g of f equals x. So previously we did a video on composition. If you haven't done that, you might want to go back and do that first. So the composition of these two functions that are inverses of each other equals x. Another property is that the domain and ranges are swapped. The values in the domain of the function f will be the same as the values in the range of function g. Also, the values in the range of function f will be the same as the values in the domain of function g. That's a little difficult to understand. Just keep in mind that the domains and the ranges are swapped. A function and its inverse will be mirror images along the line y equals x. So at the end of this lesson, we'll do a graph and we'll see what that looks like. Also note that when a function is not a one-to-one function, it may be possible to place restrictions on the function's domain in order to generate a function that is one-to-one. So in this video, I'm going to keep the functions pretty basic here. We're really only going to talk about linear functions as far as graphing or finding an inverse. But there is more complicated functions that we would talk about where we have to restrict the domain. We're not going to do that in this video. Just kind of be aware of that. Okay, so here's our example. Verify that the functions are inverses of each other. So here's our two functions. F of x equals 6x plus 5, and g of x equals x minus 5 over 6. On the previous slide, we said that the composition is always equal to x. So that's what we're going to do. We're going to do f of g of x, and then we're going to go back and do g of f of x. Okay, let's do f of g of x first. You bring the first letter, the first function, you keep that in front of the parentheses. Then the second letter, G, you put that inside the inner parentheses, G of x. Now you replace the inner function with what it's equal to. In this case, the inner function is G of x. G of x is x minus 5 over 6. So now you go to f, the function f, and everywhere you see an x, you're going to replace the x with x minus 5 over 6. So that's going to be 6 times x minus 5 over 6 plus 5. Now do a little algebra. The 6's cancel. And then we get x minus 5 plus 5, and the 5's cancel, which equals x. All right, let's do the next one. Let's do g of f of x. The g stays in front. F of x is the inner function. So replace the inner function with what it's equal to. So the 6x plus 5 will replace f of x. Now go to the g function and replace x with 6x plus 5. So we have 6x plus 5 minus 5 all over 6. Now we could do a little simplifying. The 5's cancel. Then the 6's cancel. And we're left with x. That's it. We have just verified that they're inverses of each other. If we didn't get x, then we haven't verified. Then they're not inverses of each other. But since the directions said verify, we had to get x. If we didn't get x, then we've done something wrong. So whenever you're verifying, you must get x for both of them. If you don't, it's incorrect. Go back, fix it. So f of g of x equals x, and g of f of x equals x. Here's our next example. You might want to try and pause the video, work it out on your own. Okay, it's exactly the same as the last example. We're going to do f of g of x, and then we're going to do g of f of x. Each time we need to get x. If you don't get x, then we've made a mistake. All right, f of g of x first. Replace the inner function with what it's equal to. So replace g of x with 3x plus 15 all over 2. Now go to the f function, and everywhere you see an x, replace it with 3x plus 15 over 2. So 2/3 times 3x plus 15 over 2 minus 5. Now, a little simplifying, the 2's cancel. So in the numerator, we have 3x plus 15, and the denominator will just be 3. You could separate that into two fractions, or you could factor out a 3 from the numerator, and then that 3 would cancel with the denominator. So either method would be fine. I'm going to separate it into two separate fractions using my rules of division. So 3x over 3 plus 15 over 3 minus 5. In the first fraction, the 3's cancel. The middle fraction, 15 over 3, is 5. So we have x plus 5 minus 5. 5's cancel. And we're halfway there. We got x. Let's do the second half. G of f of x. So replace the inner function with 2/3 x minus 5. Now go to the g function, and everywhere you see an x, replace that x with 2/3 x minus 5. Again, a little simplifying. We're going to have to distribute the 3. So 3 times 2/3, and then 3 times -5. So 3 times 2/3, the 3's cancel. That just gives us 2x. And then 3 times 5 would be 15. So in the numerator, we have 2x minus 15 plus 15 all over 2. Now the 15's cancel. Then the 2's cancel. And we're left with x. Perfect. So f of g of x equals x, and g of f of x equals x. Okay, how to find an inverse function and its notation. So we've used f of x now for function, and here's the symbol for inverse. It's read as f inverse of x. It's just a notation that we use. It looks like an exponent, but it's not. So it is not an exponent of -1. So I know it looks a little weird. It's an f, and then it looks like an exponent -1. And then in parentheses x, the way you say it is f inverse of x. The shorthand would be to leave out the x, and then you just say f inverse. So that third row we have there, the shorthand would be f inverse. This is read as f inverse, or the inverse of f. Here's our procedure for finding the equation of an inverse function if we are initially given a one-to-one function. Okay, so our function must be one-to-one to begin with to follow these steps. If you're asked to find an inverse, it is going to be assumed that it is a one-to-one function. Okay, here's step 1. Replace f of x with y. If it already has y, you don't need to bother, but if it has the notation f of x, then first thing you do is switch it to a y. Okay, second step is switch the x and y. Just instead of writing x, you write y, and instead of writing y, you write x. So you switch your two letters. Third step, solve for y. And then the last step, a lot of people forget this last step, replace the y with f inverse of x. All right, let's do it. Find the inverse function of this given one-to-one function, f of x equals 6x minus 11. So it's already telling us that it's a one-to-one function. We need to follow those 4 steps. What is the first step? Right. Replace f of x with y. So where you see an f of x, change it to a y. That's step 1. Not bad, not hard. What's step 2? Right, switch the x and y. So switch the x and y. That gives us x equals 6y minus 11. Step 3. Right, solve for y. So let's get y by itself. Well, to get y by itself, we're going to need to add 11 to both sides. So that gives us x plus 11 equals 6y. Almost there. What else should we do to get y by itself? Right, divide both sides by 6. So you get x over 6 plus 11 over 6. And then rewrite it y equals x plus 6 over 11 over 6. You could also leave it as one single fraction, x plus 11 over 6. Last step is to replace y with f inverse of x. And we're all done. Okay, again, the way I wrote the answer is x over 6 plus 11 over 6. If you wrote it x plus 11 all over 6, totally fine. Right, here's our next example. Why don't you pause the video, try to work it out. All right, same steps. Step 1, replace f of x with y. So y equals 2x minus 3. Second step, switch the x and y. Third step, solve for y. Add 3 to both sides, and then divide by 2. Here I divided by 2 on both sides, but I just left the whole left side as x plus 3 over 2. Again, if you want to write it as x over 2 plus 3 over 2, you can, or 1/2 x plus 3 halves. And then replace y with f inverse of x. So f inverse of x equals x plus 3 over 2, or you could write it as x over 2 plus 3 over 2. All right, last problem. So from that last example, we're going to graph each of them. We're going to graph f of x and f inverse of x. So let's graph f of x first. It's a linear function. We could pick any numbers we want. How about 0, 1, and 2? Does that sound all right? 0, 1, and 2. Plug those in or use your calculator to get the y values. Again, you might want to pause and work that out. Okay, so you should get -3 when you plug in 0, -1 when you plug in 1, and +1 when you plug in 2. Plot those points. Draw your line. Okay, one line done. Now, the next graph, again, we could choose any values we want for x. We could pick 0, 1, and 2 if you want to. But what I want you to think about was that property that we talked about earlier, that the domains and the ranges are swapped. Okay, so what I want you to choose for x is the range from the previous function. So for our x, we're going to pick those y values from f of x. So pick -3, -1, and 1. You don't have to, but it'll work out nicely. So -3, -1, and 1. So plug each of those in. Let's plug in -3 first. -3 plus 3 is 0, and 0 over 2 is 0. Now plug in -1. -1 plus 3 is 2. 2 over 2 is 1. Now plug in 1. 1 plus 3 is 4. 4 over 2 is 2. Do you see the numbers that we got? For our range, which is the y values, we got the domain of f of x, which are the x values, 0, 1, 2. Okay, again, the domains and the ranges are swapped for the function and its inverse. Let's plot those points. I use green here. Draw your line. So that is the inverse. So in blue I have the function f of x, and in, I guess it's a maroon color, is the inverse function. Now we also said that the lines were symmetric, that means mirror image, along the line y equals x. So graphically the inverse function will be a mirror image across the line y equals x. So the line y equals x is a diagonal through the graph, it has a point 0, 0, 1, 1, 2, 2, so forth. So in here we see it in red. So it just shows that each side is a mirror image of the other side. I might not have said that very well, but each function is a mirror image of the other function. It reflects across it. If you take a point on either one and then draw a perpendicular line to the line y equals x and then go through it the same distance, you'll get a point on the other graph. All right, that's it for this lesson. I know it might have got a little complicated here. I kind of see this video as just a little introduction to inverse functions. There is a lot more information about inverse functions that we're not getting into. I think that would be better for another video. So maybe I'll see you for another one. Have a good one.